For our project, we decided to test how string tension affects the decibels produced by a guitar. Our initial questions were, how does string tension affect sound, and does a super loosely tuned guitar produce a louder sound than a tightly tuned one?
We tried researching this experiment online to see if anyone had done it before, and if so, what the results were. We found that the people who had done similar experiments to ours changed the type of strings on their guitar, whereas we decided to keep the same strings but change their tension.
We predicted that if a guitar was loosely tuned, then it would produce a louder sound when strummed because it would have less string tension, which would make it easier to strum and therefore produce more vibration.
To do this, we needed a guitar, a tuner, a decibel reader, a protractor, and one person to do all the strumming for consistency.
To carry out our experiment, we first went in a quiet room to minimize potential error. Then we tuned the guitar.
On a guitar, there are 6 strings. Each string is connected to a knob, and by twisting these knobs, you can either tighten or loosen each string. The top string is called low E, and the order of the strings from the top to the bottom is low E, A, D, G, B, and the bottom string is high E. To make the strings tighter, you turn the knobs counterclockwise, and to make them looser, you turn them clockwise.
We used the protractor to measure the angles each knob made with the positive x-axis at the initial tune position. These angles were 82 degrees, 61 degrees, 18 degrees, 92 degrees, 47 degrees, and 168 degrees.
Then we strummed at the initial position and measured the highest decibel output for each strum. We did this 3 times and then took the average of the data for a more accurate result. At the original tune position, a strum produced an average of 75.7 decibels.
Then we turned each knob 30 degrees tighter from the tuned knob position, which increased the string tension. These new angles of the knobs were 112 degrees, 91 degrees, 48 degrees, 122 degrees, 77 degrees, and 198 degrees.
We strummed the new knob positions 3 times and recorded the average of the decibel readings like we did previously. 30-degree tighter strings produced around 74.83 decibels.
Next, we turned each knob 30 degrees tighter again, where each knob was then 60 degrees from the initial tune position. These new angles were 142 degrees, 121 degrees, 78 degrees, 152 degrees, 107 degrees, and 228 degrees.
Then we repeated the data collecting process again. We found that tightening the strings by 60 degrees produced about 73.87 decibels, a 1.83 decibel difference from the original result.
Then we reset the guitar knobs to the original tune position angles so that we could repeat this process, but this time make each string looser by 30 degrees and 60 degrees.
We turned each knob 30 degrees looser from the tune position, decreasing string tension. These angles were 52 degrees, 31 degrees, negative 12 degrees, 62 degrees, 17 degrees, and 138 degrees.
We repeated the data collecting process and found that the new string position produced 79.7 decibels.
We turned the knobs 30 degrees more to angles of 22 degrees, 1 degree, negative 42 degrees, 32 degrees, negative 13 degrees, and 108 degrees. And the 60-degree loosely tuned strings produced 79.76 decibels.
From our data, we found that the guitar's decibel levels increased with less string tension and decreased with tighter strings. Our results correlate to our hypothesis that the strings will produce a louder sound with less tension because the vibration frequencies would be larger than at a higher tension. Looking at a line chart of our data instead of a column chart, we can see that the graph appears to have a logistic regression. This assumption makes sense because at a certain point, the guitar would become unable to produce a louder sound. In the future, it would be interesting to see at what point the sound produced by low string tension would max out or even begin to drop.